So this is the Tegrity lecture for experiment number 2. There we go. More of my things on the side. So the objective of this PowerPoint is to highlight on important techniques and provide helpful hints for successful completion of the experiment. These are really going to help you guys get out of lab on time. It is pretty time intensive on the first week, so you guys definitely want to be multitasking as you're going through this lab. I would advise that any helpful hints that you see in this Tegrity video that are not included in the sapling manual, that you guys include those where you deem fit. So just kind of some of the background behind why this is so important. So in organic chemistry, we can change the pH of certain functional groups like carboxylic acids and amines. And when we do this, this actually changes the solubility. So in this week's lab, we have an acid, a carboxylic acid, that will react with base to form a carboxylate anion, which is stabilized by resonance. When we do this, it's generally known as the salt form of the acid. Conceptually, we can kind of think of this carboxylate anion like similar salts that we've seen in the past, like sodium hydroxide. We know that that fully dissociates in water and that it actually exists with the two charges, both the positive cation and the negative anion. When we form this carboxylate anion, it has that negative charge and then can be soluble in water because that charge is both resonance stabilized and stabilized by the sodium the sodium that can complex with that negative charge on the carboxylate anion. So the first thing you guys are going to do when you guys begin this lab is to add your NaOH to your dissolved DCM and mixture of the carboxylic acid and organic. When we do this, we want to make sure that we're doing it with a proper technique, because this can be one of the places where you automatically lose all of your product and do not properly separate your two components. Once you do add the NaOH, there is a reaction going on, so that was the reaction that I previously highlighted. So make sure that when you stopper the separatory funnel, you're keeping your finger on that glass stopper. They are known to sometimes fly off. When you shake, it can build up pressure as well, so it is important, once again, to make sure that that glass stopper is secure. You're going to invert this a few times and release any gas buildup. You're going to do this by opening the stopcock at the bottom. Make sure that when you do that, you're making it's pointed away from either your TA or any of your lab mates, including yourself. You'll do this 2 times, so you'll put your finger on the stopcock, shake it, open it, let it settle for a second, and then repeat that process. So some helpful troubleshooting techniques. So these are things that can come up with this lab and that we commonly see in organic synthesis labs. So whenever you are adding 2 solvents that are different from each other, so in this lab we have an aqueous layer and an organic layer. That's generally what you also see. Water can sometimes not like the layer that you're or the organic that you're trying to make it interact with. And what happens is you form this emulsion layer. And what I mean by an emulsion layer is that it's this bubbly layer that doesn't like to go away. What you can do when this does form is to allow it to sit longer. So we don't want you guys to waste a whole bunch of time by allowing it to sit, but we definitely do want it to sit long enough so that you're not pulling a whole bunch of the bubbles into your organic layer. This is where you can add a lot of water into that sample, and then you'll have to add a lot of drying reagent. That being said, make sure you're letting it sit long enough. Both layers should be clear, so both the water and the DCM. If if it's slightly, I guess, opaque, you just don't want it, or translucent is probably a better word, that's okay. But if it is opaque, that is not okay. If you see a lot of things floating around inside of your separatory funnel, that's usually not okay. So you definitely want to let your TA know immediately about those issues if it arises. Just kind of another helpful hit when you're draining the bottom layer, make sure you leave a small amount the first time. When you add the second wash, this is when you're going to want to let it drain entirely. Make sure you're getting as small amount of water as possible in there so that you do not have any or do not have as much water, I guess, in it as possible. The other thing is that you also don't want a whole bunch of DCM in your aqueous layer. This can mess with the reformation of the acid. So this is just kind of what I mean by an example of an emulsion and when I'm talking about an emulsion. So likely you guys will see something like this form, and if this does form, you just have to let it settle. It'll settle, and then you'll see something that looks more like this. So this is a really good example of what you guys should expect to see. As I said, it's not entirely clear. It's got a little bit of dinginess, I guess you could call it, but generally there's really no big floating particulate matter. So drying reagent, I kind of touched on why, how we come in contact with water previously in the extraction portion, but when you're doing this lab, we're going to be using sodium sulfate. Another common one that you see in organic chemistry labs is magnesium sulfate. They accomplish the exact same thing. Their purpose is to remove water from an organic layer. So the proper technique for doing this, what you guys will do is you'll have your stuff in your beaker or your flask. Well, actually, either one will work at this point. And you're going to take a spatula tip and you're going to add it in. You're going to swirl this around. Make sure that you're not swirling too vigorously and you've got solvent flying all over the place because that's lost product. But you're just going to swirl it around a little bit. If you notice that it's sticking to the bottom or that it looks very fluffy, then you're going to want to add more and you'll repeat that swirling motion. We do this to the point where there's just a small amount that swirls around and kind of floats above the rest, almost kind of like it looks like a snow globe, and this is what we deem free-flowing, and that's when you know that you've added enough drying reagent. So here's good examples. So they've added about a spatula tip, maybe a little less in this point, so you want a little more than that to begin with. It's beginning to clump at the bottom. That means that it's pulling in the water. It's still clumping, so you want it to add more if you have something that looks like this. This looks pretty good, so you've got, some of it's floating in solution, you've got some stuck at the bottom, but that ultimately means that you're pulling out the water that's in there. So when you guys reform the acid, so this is the aqueous layer only, so definitely make sure that you're labeling your organic layer from your aqueous layer. You should only need 7 milliliters of hydrochloric acid. However, in the procedure, it should show an increased amount to account for variations in the mass that you guys weigh out. If for some reason you notice that your acid is not reforming with 7 milliliters, that's when you can add a little more. I would also suggest when that does happen, getting to that 7 milliliters point, you put it in the ice bath and then proceed to add more. This will just encourage recrystallization to happen faster. So your guys' reaction in the carboxylic acid that'll be reformed should produce a very robust reformation. So you guys should see something that looks like this. When you guys are dropping it in with a dropper, you guys should also begin to see the kind of a white particulate matter appearing as you're dropping it in. If you begin to see that, then you know you're in the clear, you know that you're doing the right thing. So the removal of the DCM from the organic, so this is after you have filtered off your sodium sulfate drying agent. Do not do this portion before you have filtered off, because it will not work. So why we're doing this, we have to remove the DCM because the DCM is not our recrystallization solvent. So we've got to get it off so that then we can do the recrystallization step. For this, you definitely want to filter your DCM into a 50 milliliter Erlenmeyer flask with a stir bar. We are not going to use boiling chips, and the reason we're not using boiling chips is because it'll be very difficult to separate out your organic solid from those boiling chips. When you are boiling your DCM, it's important to note that the boiling point of DCM is pretty low. It's about 40 degrees Celsius. So we want to not overheat that DCM so that we have DCM, violently boiling. So with your setup, you will want that boiling point to be around 40 to 60 degrees Celsius. It is possible, and it is likely that at this point, once you have boiled off the rest of the DCM, you will have you'll reach the melting point of the organic, and it will actually exist as a liquid. So make sure that you're paying attention for that, even if you see, you've got some persistent, liquid at the bottom. That's a good sign, as long as you know that you've reached that 40 degrees Celsius point. For specific instructions on heating, make sure you're listening to your TA at the beginning of lab. One other important thing is that we're going to be using mini hoods. The DCM vapors are potent, so we need to pull out as many of those vapors as possible. Because we are limited in our hood space, this can be overwhelming for some. So if you begin to feel lightheaded, make sure you let your TA know immediately. So I kind of got to this, or alluded to this in the previous slide, but the unknown is likely to melt from the boiling step. So you may see a layer that is brownish in color. So DCM is clear. If you see something that is not clear, you likely have your product separate from your DCM. If you begin to notice brown fumes, that means that you are actually boiling off your organic. So you'll want to do is you want to turn off your mini hood, remove your flask from the heat, and cover it immediately. This just will prevent your unknown from vaporizing and then you losing all of your product. When you are done heating off all of your DCM, and if you do not see crystal formation after a few minutes at room temperature, place in an ice bath. Usually this will prompt crystal formation almost instantaneously. However, if crystals are not formed after several minutes in the ice bath, we're going to have you guys proceed to the recrystallization step with this layer. So here's just a visual depiction of kind of what we're asking you guys to set up. So we've got a clamp holding the mini hood. We've got the mini hood itself. So notice that the mini hood is hooked up to the aspirator. The mini hood is completely over your 50 milliliter Erlenmeyer flask. So just to eliminate the number of fumes that we have in the room. This is not necessarily the full setup. Your TA may tell you to run it in a water bath. If that is the case, you'll want to have your water bath heating up before you reach this point. So recrystallization. Recrystallization is a means of removing impurities from products without running column chromatography. So when you guys do this, you guys are going to heat both of the recrystallizations solvents separately. One thing, it's mentioned in your lab manual, but ethanol has a much lower boiling point than water. So make sure that you are not overheating your ethanol. You do not want your stuff to boil. You want it just to be slightly warm, not to a boil. When you're dissolving your acid and organic in the appropriate solvent, you want to use the smallest amount possible. This is because if you add too much solvent, it may prevent the recrystallization from occurring, and then you may have to boil down some of the solvent before you can try to recrystallize again. Once you have added the small amount of the recrystallization solvent to your organic or acid, you're going to place it into the ice bath to allow to recrystallize. I would suggest that you find a way to clamp the two into an ice bath, or to use a small amount of ice in the ice bath. The other thing you guys could do as well is use a smaller beaker and create an ice bath in that, so that it doesn't tip over. If it does tip over and you guys lose your product, that's when we can allow you guys to purchase more of the product from the TA. However, you guys will receive a 1-point deduction on the lab per product that you need more of. One other important thing to kind of touch on is that the organic may take longer to recrystallize than the acid. So if you do have one that recrystallizes really quick, but the other isn't recrystallizing at the same speed, don't worry too much. It's possible that the one of takes longer than the other. So for week 2, you guys should already have gotten the recrystallization done. The reason we have you guys get to that point is because one of your recrystallization steps is water, and you're rinsing with cold water, and water sticks to things, and so this will allow your stuff to dry over a week's time period. But when you guys do come back, you'll be expected to run melting point on both of the recovered unknowns and the 2 standards. So that's a total of 4 different melting points that you guys need to collect. Your TLC, it's going to be performed in 5:1 hexane ethyl acetate and 0.1 acetic acid. The reason we use this and the reason we have the acetic acid is because when you run TLC on a carboxylic acid, you will not get it to move unless you have acetic acid. So that's why that component is in there. You're going to do that on the 2 standards and both of the recovered unknowns. So you should have a TLC plate, and on that TLC plate have 4 spots. You'll also be doing IR. So there is an IR video that should be available for you guys to watch and know how to operate the IR as well as clean the IR. It's really important that you guys come with that prepared, because there are approximately 24 students per lab and 48 between the 2 labs that need to get 2 different IRs run. You'll be just running this on your recovered unknowns, not on the standards, so that's important. You're only running this 2 times, but that's still a lot for the number of students that we have. Your IR should be stapled to your lab report, so make sure that you do that. In addition, you're going to want to circle and label the specific characterizations of the peaks, including the approximate wave numbers. So here's an example of kind of what I'm talking about. So in this, they have a carboxylic acid, so they're labeling the carbonyl peak, and they're saying, that carbonyl stretch at approximately, 1710. Make sure that you guys are saying all of these and that you're identifying the appropriate peaks on each one. The other thing that you guys also need to do is kind of give your analysis of whether or not this was successful. So if you see peaks that you wouldn't expect to see, explain that. If you see or if you don't see peaks that you would expect to see, say that. So there definitely needs to be an analysis portion in addition to just stating these. If you have any questions, make sure that you are coming to office hours and getting any sort of clarification on anything that was presented in this PowerPoint, but specifically, this analysis, since I know that IR analysis is not something that is presented until later in the semester.